Okay, we're going to look now at lunar phases, eclipses, and seasons, Earth and Space 4. These are learning intentions we're going to cover as we're going through this. And we're going to begin by looking at rotation and revolution. So rotation is when an object revolves or turns around its own axis. So this is the Earth spinning around its own axis, whereas revolution is when an object is traveling around an external point. So the Earth is revolving around the Sun is the external point. Okay, the Earth has a 24-hour rotation period. Okay, it rotates or spins around its own axis every 24 hours, and the Earth revolves around the Sun in 365 in a 0.25 days. So that's the revolution period. Our calendar year is 365 days, so that extra 0.25 of a day is made up every 4 years during a leap year. The Moon, as we'd see later on, has its own revolution and rotation periods. If the Earth is facing the Sun, obviously it's daytime, and if it's facing away from the Sun, it's nighttime. But because of the Earth's tilt, okay, the length of day and night varies wherever you are on the planet and in what season you're in. The Earth's tilt is 23.5 degrees from the plane of orbit around the Sun. This tilt is what causes the seasons to change in temperature, and it's what causes the differences in length between night and day. If we're looking at this diagram, if you lived in the northern hemisphere, okay, you're tilted away from the Sun. And if you live at the very North Pole, you're going to be in total darkness for 24 hours a day. So that can last for a number of weeks. In the summer, the opposite occurs. You're going to be tilted towards the Sun, so you'll have a longer time pointing towards the Sun, so you end up with a longer day. In this diagram, the northern hemisphere is tilted towards the Sun in summer. So the northern hemisphere receives more direct heat. It's pointed more in line with the Sun. Compared to the southern hemisphere, the sunlight is spread over a larger area. The southern hemisphere is tilted away from the Sun. Okay. The northern hemisphere isn't always tilted towards the Sun. As the Earth's orbit the Sun, it's always tilted towards the same part of the galaxy. Sometimes it's tilted away from the Sun, sometimes tilted towards the Sun. In June, July, and August, the northern hemisphere is warmer because it's tilted towards the Sun at that time of the year. In December, January, February, the northern hemisphere is cooler because it's tilted away from the Sun. It's interesting to note that the Earth is closest to the Sun during wintertime. It's not what you expect, but because the northern hemisphere is tilted away from the Sun in wintertime, it feels colder for us. So if we look at when this tilt is at a maximum, okay, in relative to the Sun, those are known as Salsa Time. So we have the summer solstice and the winter solstice. In the summer solstice, the Earth is tilted away from the Sun at its maximum. So the Sun is either at its highest point in the sky for summer solstice or the lowest point during the winter solstice. Autumn and spring equinoxes, the Sun is neither tilted away or towards the Sun. So the length of time at spring equinox of daylight is approximately equal to nighttime. Okay, looking now at the Moon orbit. The Moon orbits the Earth in 27 days and also rotates on its own axis in 27 days. This results in the same side of the Moon always being visible. This effect is caused by the force of gravity between the Earth and the Moon and is sometimes called tidal locking. Quick look at tides. Tides are caused by the gravitational pull of the Moon on the oceans, and that creates a bulge. The Earth's spin results in bulges on opposite sides of the Earth. As the Earth rotates, it passes through two of these bulges of water every 24 hours, resulting in high tides 12 hours apart. Okay, now to look at lunar phases. The lunar phases describe the changes we see in the Moon as it orbits around the Earth. For example, in a full moon, the moon is fully illuminated by the sun. For a half moon, we only see half of the moon illuminated. Um, this occurs during the first quarter and the third quarter of the stage. So during the first quarter, we're going to see the right-hand side of the moon illuminated, and during the third quarter, we're going to see the left-hand side of the moon illuminated. You'll notice on the diagram that the viewer is inverted at the bottom of the diagram, looking at the third quarter. So we have these phrases to look at as well. A waxing moon means that the illuminated part of the moon is getting brighter. So we're getting more and more of the moon is becoming visible, is becoming illuminated. A waning moon means less of the moon is being illuminated. So waxing moons are seen in the first 14 days of the lunar cycle, and waning moons are visible for the second 14 days of the cycle. For a crescent moon, less than half of the moon is illuminated. So it starts off as a small sliver of the moon is illuminated. This is a crescent. That crescent grows and grows until it becomes a quarter. And after the quarter, it's waxing. A waxing moon, more of the moon is illuminated than half. Excuse me, in a gibbous moon, beg your pardon, a gibbous moon, more than half of the moon is illuminated. So we have those two important words. Crescent moons is less than half of the moon is illuminated, and a gibbous moons means that more than half of the moon is illuminated. Now, I recommend you're able to label or draw a diagram like this, showing the sun on the right-hand side of the screen and the moon orbiting anti-clockwise. Being able to know all of those stages, from new moon to waxing crescent to first quarter, waxing gibbous, full, waning gibbous. Now the moon is starting to get dark again. The third quarter, what we're seeing here is what the moon would look like from Earth. Okay, and remember, at the bottom of the diagram, the viewer, the little person on the Earth, would be inverted. Occasionally, the moon can pass in front of the sun, blocking it, resulting in a shadow on Earth. This is known as a solar eclipse. So when you're drawing a solar eclipse, it's important to remember that the moon is between the Earth and the sun. That's the important thing. The moon is located between the Earth and the sun during solar eclipses. A solar eclipse will occur during a new moon, okay, but it won't occur in every new moon because the angle of the plane of the moon's orbit around the Earth is slightly different to the plane of the Earth's orbit around the sun. So they only line up every 18 or so months. So approximately every 18 months, you'll have a solar eclipse somewhere on Earth. But for example, in Ireland, a solar eclipse won't be visible from Ireland, maybe every 300 to 400 years. In a lunar eclipse, occurs when the Earth's shadow falls on the moon. So when you're drawing this, Earth is in the middle in diagrams of a lunar eclipse. Lunar eclipses will happen during a full moon, but not every full moon, because the plane of the Earth's orbit around the sun is different to the plane of the moon's orbit around the Earth. Now, in the slide presentation that I'll send you also, there's 6 videos, and I recommend you play each of these 6 videos. They're about 5 or 6 minutes each. Okay, and it'll help you come to understand the topics we've covered. At the end, there's some sample questions that have come up in past exam papers, and I'll be giving you questions similar to these in worksheets.